robot, the major important point with respect to the gear train is ratio of output torque to the input torque is constant and is equal to the gear ratio. So the importance of gear ratio we'll be able to see over here, because with the same ratio even the torques are getting transmitted through them. Okay, so this is how the importance of gear ratio with respect to the gear trains, as well as torque being transmitted, or the number of teeth whatever you try to take into account, or angular velocities whatever maybe, that in that aspect also if you try to take. Okay, so all these things are actually trying to give you on the same ground. Fine, let us see this. You have got two gear wheels. As of now, this is your driver. A is the driver having 20 teeth. B is the driven having 80 teeth. Driven to the driving ratio, if you try to take gear ratio, 80 by 20, 4 by 1, 4 is to 1. Means for every 4 rotations of the driving gear, the driven gear makes 1 rotation. So means there is a reduction in the speed. Say 20 is this, 80 is this. For against 4 rotations of this, 1 rotation of this is going to happen. Because of that, when you try to see the speeds between driver and driven, when you compare them, when you try to provide comparison, NV is smaller than NA. There may be some other instance wherein V may be the driver, A may be the driven, in which case we are going to have a step up in the speed, increase in the speed. Okay, so it's all depending upon the manner in which you are trying to give connectivity and connectivity to the driver. Once you try to connect A to the driver, B will become the driven, and if you connect B as the driver, A will become the driven. Anyway, the basic purposes of gears, or the responsibilities or features that are going to be generally satisfied by the gears are: first one, if you want, you can reverse the direction of rotation. See here, A is trying to take the rotation in clockwise. The gear which is in contact with A is trying to make, rather it is trying to rotate in anti-clockwise. So this is how, if you want, you can reverse the directions of rotation. Then the next one, to increase or decrease the speed of rotation. Say if A is the driver, driven wheel is going to be rotated with lesser speed. If B is the driver, A is going to be made rotated with higher speed. So depending upon the requirement, if you want, we can either step up the speed or you can step down the speed. So that way it is possible for us. Okay. Then the next one is to move rotational movement to the different axes. To move rotational movement to the different axes. See, A is one axis, A wheel is having one axis, wheel B is actually having some other axis. Driver axis was actually A. From there, the movement is actually transmitted to the driven wheel B, which is actually some other axis. So this is how the movement you are trying to, rotational movement you are trying to transfer from the axis A to the axis B. This is another requirement that can be satisfied. Then the fourth one is to keep the rotation of the two axes in synchronized. It is something like, irrespective of the RPM you have given for A, in correspondence to that, B RPM is going to be satisfying this particular gear ratio 4 by 1. Okay, so satisfying this particular gear ratio, X, if that is the RPM being given for wheel A, then with this particular ratio, whatever is possible for this wheel B, that respect to RPM only is going to be transmitted to that. Same is the story. Okay, so if the text value is 1000, corresponding to that B value RPM is going to be. If that A value RPM is 500, corresponding to that, satisfying the gear ratio, whatever the value comes for V, that is going to be the value for S. So this is how the rotation of the two axes, means two gear wheels, since they are actually having mating contact between the teeth, their motion is obviously constrained to have a synchronized path. Okay, so this is how a particular gear train, if you want to keep up, in order to satisfy these requirements, it is definitely possible for us to go ahead. Then if you try to consider tractive effort, it is actually being calculated by you all. I think in the name of tractive force itself, when a vehicle is moving up the hill or something like that, maybe on a slope, when you try to, I think you all remember that this particular aspect has been calculated, I think in your DOM, dynamics of machinery. But altogether, though they say that it is the friction between the wheel and the road surface which are all maintaining contact, altogether this is nothing but a force that is essentially required to pull the load. That pulling is possible when there is sufficient grip between the wheel and the road surface. You may have the capacity of an engine to pull it with, but if that particular engine tires and the road friction is not sufficient enough to bear that particular effort or the force, then it is not possible to pull that or push it. In addition, we experience the slip condition over there. Okay, so we can even see the importance of this particular slip over here, in particular in the level of traction. Say when a vehicle is coming down the hill, that time, if that particular vehicle was made to travel with high velocity, reasonably good velocity, then what happens, even if you apply brake, the grip between the road and the tires is not sufficient to hold that vehicle properly, because that downward force is going to be predominant rather than the friction between the road and the wheels that contributes, that contributes in this particular direction. Say the wheels would have got stopped by applying brakes, but the friction between the wheels and the road is not sufficient. That contributes towards the skip of it. Okay, that contributes towards the skip of it. Okay, so that is how that particular vehicle may fall down in the valley. In order to give you some connectivity between the gears and the tractive effort and the speed, this particular picture is going to give us some clarity on that. See here, maybe I don't know how far this particular figure is actually true. With respect to gear 1, I am okay, because when the vehicle is at zero condition, that time we try to start the vehicle with the gear 1. Gear 2, though they have tried to extend this up to 0, please don't assume it to that. You can assume it maybe up to this particular zone, nearer to this particular zone. So that gear 1 needs to be applied in the beginning. Gear 1 needs to be applied in the beginning. Then after attaining certain speed, if you look at this, the speed is actually nearing to 35 units, kilometer kmph. I don't know what type of vehicle is this. We will not move the vehicle on gear 1 up till this, hardly for about 5 to 6 kilometers per hour. The moment we make the vehicle to move on gear 1, immediately we will have mobility. The moment we get that mobility, what we do is we immediately switch over to the gear 2. So you can see here the gear 2. The other way you can imagine, gear 2 is capable of handling the task tractive effort close to 4,250 newtons. So gear 1 is capable of handling the tractive efforts close to 7,250 for this type of vehicle. Gear 2 definitely not possible to raise its effort up to that, but it can bear the tractive efforts up to 4,250 units. Coming to the gear 3, it can hardly handle we are close to 2,700 units. Okay, so gear 1 is essentially required in the beginning, because in the beginning the tractive effort is close to 7,250. Soon after going ahead with that particular one, the speed picks up, then the effort required is also going to be reduced. So the moment it reduces or comes to 4,250 close, then we try to shift the gear to gear 2. Then further, if the speed increases, then the requirement of tractive effort decreases. Say if it comes down to 2,750, that time we try to shift the gear to gear 3, and then we try to go on proceeding. So this particular graph is going to give us an idea on some type of vehicle. I don't know what type of vehicle it is. Some type of vehicle, the requirements of tractive effort in the from the beginning, in between, and then to the end, for which we are trying to take the support of appropriate gear ratio. So this is the kind of input what we will be getting from here. Okay. Then this is another kind of plot. What is again not bothering about the gear ratios and all, but this is trying to give you again the plot between tractive effort and the speed. Train resistance line is actually this. Initially, resistance is going to drop down. This is the zone wherein the tractive effort, or rather the load, is going to be more. Pulling effect required is more and more. Okay. Later on, that is going to be reduced, or that resistance is going to, train resistance is going to go on increase. Okay. Then if you go to the next kind of information, how many types of robotic drive systems are there? This point we have already seen earlier in the earlier slides also. Electric drives, hydraulic drives, pneumatic drives. Nowadays, in majority of the situations, we are trying to recommend to go ahead with providing electric drive systems. The basic reason is they are very clean. We will not get any maintenance issue, major maintenance issues over there. Okay. The idea is for hydraulic and pneumatic, you need to have some cylinder, hydraulic cylinder or pneumatic cylinder. Maybe you can consider that on this ground. You are going to have one inlet and one outlet. So through this, in order to have connection, you are going to have pipeline, and through those pipelines, pressurized fluid is going to be supplied. Okay, so at no point of time there should not be any leakage within that particular pipeline. Okay, once we have some kind of leakage, that gives a failure for our system, because you are trying to give an input to do something, because of the leakages that are present at the ceilings or at the joints level, then whatever the pressure you wanted to transmit, with which you wanted to make the actuator to function, it will not. Same is the story even with the case of pneumatics. Even over there, you are going to have a sort of devices like that. You can see those images. The similar kind of image, whatever you are having it for hydraulic, you are having. Okay, for electric, you don't have so many complexities. Hardly the power cable supply, you are going to go take it over there, and you are going to connect them to them. You may be making use of some built-in gear train mechanism. Okay, so that particular feature is again have become a built-in mechanism. Power through some cables you are going to supply directly to that. So hardly some spark might come. That situation will arise in even on normal ground. So that is only the problem with which we need to be careful with respect to the electric drive. And of course, hydraulic drives, if you consider, if you want to have high power and high lift capacity, that time we try to recommend to go for hydraulic devices. This we are experienced even. The all earthquake equipment, heavy equipment, bulldozers, all those things, when you try to consider, they are all trying to work with maybe heavy lift cranes. They are all working with hydraulic devices. Then coming to the pneumatic, they are limited to smaller robots and simple. Basically, they have been put in use for material transfer applications. Okay, material transfer in the sense we doesn't need such an accuracy kind of motion. Okay, so from one location to the other location, majorly the material is going to be moved. For some such set of applications, we are trying to put them in use. So altogether, what is that we can conclude was actuators are basically the devices that is driving the robotic arm. So this is the major device that drives the robotic arm, because all the joints that are associated with the robotic arm and the body, and of course even on other grounds, they're all being connected with a particular type of joint, as well as at each and every joint some actuator drive has been mounted on it. So unless otherwise you give signal and power to the actuator drive, it is not possible for you to provide some relative motion between those links. Okay, so as we have seen in the earlier slide, there are three main types of actuators: electric, hydraulic, and pneumatic. Hydraulic and pneumatic actuators are generally used for driving the prismatic joints as they produce linear motion. These actuators are also known as linear actuators. Not rigidly concluded with this particular statement. Sometimes, depending upon the requirement, if you want, you can use them even for rotating actuators. But majorly, they are trying to confine themselves for linear. Then coming to the electric motors are more suited to drive the revolute joints as they produce rotation. Once again, we can, since we know the mechanisms that convert rotary motion to the linear motion with the support of single slider crank mechanism, since we have flexibility to, convert the sliding to rotary or rotary to slide motion. So alternately, if situation demands, you can go on using them. Okay. Anyway, this is actually a voltage principle which has been put in use in hydraulic type of systems. The moment this first statement you have come across, you would have recalled, if external pressure is applied to a confined fluid, then the pressure is transformed without loss to all the surfaces in contact with the fluid. Okay. Uh, you would have visualized the actions what all happened over here. Maybe the Bernoulli's principle, or maybe this particular principle they have tried to put in use even to know the weight of the object, whatever has been lost in a fluid when it has been dumped in. So much of story as a bit by bit pieces I am trying to may give you a recall. Altogether, force is nothing but pressure. Pressure is nothing but force per unit area, or force is nothing but pressure multiplied by area. So when you have a small opening there, if you try to apply some pressure, and in a container, at one end if you apply pressure, to the other end that is getting transmitted, provided the fluid whatever you have used is not compressible. And if it is compressible, there are some other approaches what has to be, even there that pressure force is getting transmitted. But of course, the extent of compression is going to be there. That aspect also you are going to take into account while you are trying to consider such sets of fluids. So the word fluid can mean both a gas and liquid. That is obvious. You're all gentlemen, and you know what is the meaning behind that. This system is recommended to use when large amount of forces are required. So this particular conclusion we have seen in the earlier slide also. Hydraulic transmission of energy and control by using the liquid as the working medium. So this is obvious. In the hydraulic actuator, liquid is actually one of the working medium, hydraulic oil. It uses the hydraulic pump to convert mechanical energy to raise the liquid pressure, rather to increase the pressure energy of the liquid. It takes the support of control valves, hydraulic cylinder and pipes. So in this particular statement itself, he has given a hint that this hydraulic actuator is going to make use of hydraulic pump, control valves, hydraulic cylinder and pipes, interconnecting pipes. The liquid pressure being raised with the support of hydraulic pump can be converted back to mechanical energy. So this can easily be realized by any mechanical person. This can easily be realized by any mechanical person that the reciprocative motion and rotary motion can be converted from one motion to the other. If you decide to convert from reciprocatory to rotary, it is quite possible. If you wish to convert rotary to reciprocatory, that is once again possible. The working medium is liquid hydraulic fluid. Its function is similar to belt, chain and gear. A bit hard to imagine. Function of a belt, function of a chain, function of a gear. We are able to visualize over there. So the functions being delivered with the support of these three, similar function we are able to get by with the support of this hydraulic fluid also. That is what we are supposed to imagine at this particular end. Then each hydraulic actuator consists of the following parts. See, few out of these things need not be. Depending upon the configuration, spring return piston, spring return word may be there or not. Piston will be there. That piston may be supported by a spring in order to bring back to the original position or not. It depends on the kind of configuration whatever you are having. Even here, single acting cylinder it could be, or double acting cylinder it could be. And of course, hydraulic valves and hydraulic accumulators, they are going to be there obviously. Okay, so I'll stop my presentation at this particular slide. Let me start.